Machine learning is a branch of artificial intelligence that involves building systems that can learn from data and make predictions or decisions without being explicitly programmed. The key idea behind machine learning is to develop algorithms and models that can automatically improve their performance by learning from data. There are three main types of machine learning. Supervised learning. This is the most common type of machine learning. It involves training a model on labeled data, i.e., data that has been labeled with the correct output or target variable, and then using the model to make predictions on new, unseen data. Examples of supervised learning include linear regression, logistic regression, and decision trees. Unsupervised learning. This type of machine learning involves training a model on unlabeled data and then using the model to identify patterns or structure in the data. Examples of unsupervised learning include clustering and dimensionality reduction. Reinforcement learning. This type of machine learning involves training a model to make decisions in an environment by receiving feedback in the form of rewards or penalties. Examples of reinforcement learning include game-playing agents and robotics. Machine learning algorithms and models can be further categorized as instance-based learning. This type of algorithm learns by storing and comparing new examples with past examples. Model-based learning. This type of algorithm learns by building a model of the problem, and then uses this model to make predictions. A key aspect of machine learning is the ability to improve the model's performance over time by adjusting the model based on new data. This is done by using a process called training, which involves using a dataset, training dataset, to adjust the model's parameters so that it can make better predictions on new data. Machine learning is widely used in a wide range of applications such as image and speech recognition, natural language processing, recommender systems, predictive modeling, robotics and self-driving cars. Overall, machine learning is a powerful tool that allows systems to learn from data and make predictions or decisions without being explicitly programmed. It's a rapidly growing field with a wide range of applications, and it's changing the way we interact with technology. Supervised learning is a type of machine learning where the model is trained on labeled data and then used to make predictions on new, unseen data. The two main types of supervised learning are regression and classification. Regression is a supervised learning method used to predict a continuous outcome variable, also known as the response or dependent variable, based on one or more predictor variables, also known as independent variables or features. The goal of regression is to find the best fitting line or equation that describes the relationship between the predictor variables and the outcome variable. The most common types of regression include linear regression, polynomial regression, and logistic regression. Linear regression is a simple approach which finds the best fitting line that minimizes the sum of the squared differences between the predicted values and the actual values. On the other hand, classification is a supervised learning method used to predict a categorical outcome variable, also known as the response or dependent variable, based on one or more predictor variables, also known as independent variables or features. The goal of classification is to find the best decision boundary, also known as a classifier, that separates the different classes. The most common types of classification include logistic regression, decision trees, random forest, naive Bayes, and support vector machines, SVM. In logistic regression, the model learns the probability of a given input belonging to a particular class and then makes the prediction based on the highest probability. In decision trees, the model learns a series of decisions or rules that lead to a prediction. Random forest is an ensemble learning method which combines multiple decision trees to make a prediction. Naive Bayes is a probabilistic algorithm based on Bayes' theorem which makes predictions based on the probability of an event occurring. Support vector machines, SVMs, is an algorithm that finds the best decision boundary by maximizing the margin between different classes. Unsupervised learning is a type of machine learning where the model is trained on unlabeled data and then used to identify patterns or structure in the data. The goal of unsupervised learning is to discover hidden patterns, structure, or relationships in the data. Unlike supervised learning, unsupervised learning does not have a specific outcome variable that the model is trying to predict. There are several types of unsupervised learning methods, such as clustering. This method is used to group similar observations together based on the similarity of their attributes. The most common types of clustering are k-means and hierarchical clustering. Dimensionality reduction. This method is used to reduce the number of features in the data while preserving as much information as possible. The most common types of dimensionality reduction are principal component analysis, PCA, and linear discriminant analysis, LDA. Anomaly detection. This method is used to identify observations that are different from the rest of the data. These observations are known as anomalies or outliers. Association rule mining. This method is used to find patterns or rules in the data that indicate a relationship between different variables. One of the main applications of unsupervised learning is in data exploration and data visualization, where it can be used to identify patterns and structure in the data that might otherwise go unnoticed. Unsupervised learning is also used in anomaly detection, which is used in fields such as fraud detection, network intrusion detection and healthcare to identify abnormal or unusual events. Additionally, unsupervised learning is used in market basket analysis to identify items that are frequently purchased together and in image and speech recognition to identify patterns in the data. Ensemble methods and model selection are techniques used to improve the performance of machine learning models. Ensemble methods are a type of learning technique that combine the predictions of multiple models to improve the overall performance. The idea behind ensemble methods is that by combining the predictions of multiple models, the ensemble will be more robust and less prone to overfitting than any individual model. There are several types of ensemble methods, such as bagging, bootstrap aggregating. This method involves training multiple models on different subsets of the data, and then averaging the predictions of all the models. Boosting. This method involves training multiple models in a sequence, where each model tries to correct the errors made by the previous model. Random forest. This method is an ensemble of decision trees, where each tree is trained on a random subset of the data. Stacking. This method involves training multiple models on the same data and then using the predictions of these models as input to a new model, which makes the final prediction. Model selection is the process of choosing the best model for a given task. There are several techniques used to select the best model, such as cross-validation. This method involves dividing the data into training and test sets, and then evaluating the performance of the model on the test set. Hyperparameter tuning. This method involves training multiple models with different sets of hyperparameters, and then selecting the model with the best performance. Model comparison. This method involves comparing the performance of different models on the same task, and then choosing the best model. Ensemble methods and model selection are important techniques in machine learning because they help to improve the performance of models, reduce overfitting, and make more robust predictions. Overall, ensemble methods and model selection are techniques used to improve the performance of machine learning models by combining the predictions of multiple models or by selecting the best model for a given task. These techniques help to make the models more robust and accurate, and they are widely used in many different applications of machine learning.